First, we discuss various pressure volume diagrams. Which in short you call PV diagrams. You understand? In this kind of diagrams, the graph which you will be plotting, that will be having volume on horizontal axis and pressure on vertical axis. Now you see, if you put a point here, अगर एक प्रेशर वॉल्यूम डायग्राम पे आप एक पॉइंट लगाते हैं, then you understand it is showing a fixed value of volume and pressure. That means that is indicating the state. State word has technical meaning for us. State of the gas is denoted by a point here. But in case, let us suppose you are joining several points, you are drawing a straight line and showing an arrow, then that particular graph is essentially showing a process. For example, here let us suppose I have drawn a straight line which is exactly horizontal. Then this is indicating a kind of thing that there is a situation or a process which we call, in which the pressure is remaining constant but the volume is constantly increasing. Understand? A point was a state, but in case you have drawn a curve or a straight line along with an arrow, then that is indicating a kind of process. For the sake of simplicity, in our syllabus you happen to confine yourself to processes like this. You understand? Let's suppose I have drawn 4 processes. Then you see the first line which you have seen, this will be called isobaric process. This is isobaric, means the pressure in this particular process is remaining constant. So you will be calling it isobaric process. If you consider this part, then this is drawn for isothermal process, in which the temperature of the system remains constant. Any slow process can also be approximated to an isothermal process. So whenever in the question slow process has been written, you will be treating it as isothermal process. The third line which you see, that is drawn for adiabatic process. You understand? This is for adiabatic process or diabatic process, whatever you call. And this is also indicating a fast process, in case sometimes in the question it is mentioned that the change is sudden, then you will be calling it adiabatic. And the vertical line which you see here, in this case you will see that the volume is remaining constant, pressure is going down, pressure is changing, but volume is remaining constant. So such processes are called isochoric. Sometimes this is also called isometric process. So this fourth line which you see, this is called isochoric process. Now in all the 4 processes, you can clearly see that the volume has the tendency to increase, because you see the graph is going from left to right, so volume is increasing in all such cases. Then I can call it all such process for expansion. You see, when the gas will be expanding, then only the volume will have the tendency to increase. So you can say all 4 processes, they correspond to the expansion process. You can have all such processes for compression as well. Let us suppose I name them, say 1 to 2 is isobaric, 1 to 3 is isothermal, 1 to 4 is adiabatic, and 1 to 5 is isochoric. Now let us suppose I demand that you draw all these 4 processes for compression situation, compression process, then how will you move? Then you see on the pressure volume diagram, in case you are interested in showing all such processes for a case of compression, then the same graphs will be taking shapes in this form. You understand? This will be 1 to 2, this will be 1 to 3, this will be 1 to 4, and this will be 1 to 5. So here you can again correlate. 1 to 2 will be isobaric. This is isobaric process in which pressure is remaining constant. 1 to 3 will be isothermal process. 1 to 4 is adiabatic process. And 1 to 5 which you have, that is isochoric process. Understand? जैसे हमने एक्सपेंशन में शो किया है उसी लाइन पे हम इसे कॉम्प्रेशन में भी शो कर सकते हैं. सो दीज आर द 4 मेन प्रोसेसेस इन विच आवर डिस्कशन विल कन्फाइन. ये कॉम्प्रेशन की सिचुएशन है और यही सारी सिचुएशन यहां पे एक्सपेंशन के केस में हमने ड्रॉ किया है.